Hi everyone, and welcome to the Breaking Down Biology blog Q&A session. My name is Michael He, and today I'm joined by UCSF scientist Dr. Diana Alba, the lead author of the paper A Distinct Form of Subcutaneous Fat, also known as SAT, Fibrosis Predicts Insulin Resistance in People with HIV. Thank you for taking the time to join us today.
Thanks for having me.
Awesome. So today we are going to be discussing Dr. Alba's paper that was published in medRxiv. Dr. Alba, we're fascinated by your article and how specifically SAT fibrosis can contribute and even potentially predict insulin resistance in people with HIV. To better understand the molecular changes behind this process, your team analyzed gene activity using a target fibrosis-related gene panel. Could you explain the significance of using a gene panel in this context and what it means when certain genes such as COL14A1 are found to be upregulated or downregulated?
Right. That is a great question. So maybe to give some background, we have known for some time that where the fat or the adipose tissue is stored and how it actually functions matter much more than how much fat a person has. So if you have healthy adipose tissue that can actually expand and store energy, it's actually going to protect maybe the other organs from lipid overload, right? And so when that capacity is lost because the tissue becomes inflamed or actually fibrotic, and when I say fibrotic, we mean when the tissue is stiff due to collagen buildup, and so it cannot expand anymore, right? So the idea is that this fibrosis prevents the normal fat expansion and forces the lipids to be deposited in places that they don't belong to, such as the liver or the muscle or the heart, which actually drives insulin resistance. This process not only limits lipid storage, but also triggers chronic inflammation, which actually interferes with insulin signaling and contributes to systemic insulin resistance. And so for people with HIV, this process are actually amplified. Even though they might have normal weight, they have a chronic low-grade inflammation that actually persists due to immune activation linked to the virus and actually to the long-term antiretroviral medications that they take, right? We use a targeted fibrosis related gene panel to actually explore how these molecular changes actually directly in the adipose tissue. We use subcutaneous adipose tissue. This allowed us to focus on genes involved in collagen production, extracellular matrix remodeling, as well as inflammatory signaling. We use a panel that has 700 plus genes that have not been really studied in adipose tissue. When genes like collagen 14 actually were upregulated, it pointed to active tissue remodeling and immune cell recruitment. When we think about adipose tissue fibrosis, we think about like collagen 3, 1, 6 in humans. And so it was really interesting to actually see something like collagen 14 maybe pointing to a different pathway that is activated. And in contrast, there are several genes that are usually linked to lipid handling and storage, such as PNPL3, that were downregulated, right? So that suggests that the tissue's capacity to store fat is actually compromised, leading to ectopic fat deposition in other organs. If we actually integrate these gene expression patterns, we can see how inflammation and fibrosis actually get together or converge to drive insulin resistance independent of obesity in this particular population.
Thank you for sharing. Wow, it is fascinating to see that a gene panel could test for multiple genes in a specific condition like SAT. And while reading, we were also intrigued by your uses of dual energy X-ray absorptiometry, or known as DXA, and that was used to access body fat distribution and hydroproxylene assays to express fibrosis. So my question for you is about your methodology. What made DXA and hydroproxylene the best tools for this study? And were there any technical challenges in measuring fibrosis in small fat samples from the biopsies?
We use the DEXA scan because it actually provides a more precise and regional breakdown of body composition. You can actually see how much fat, muscle, and bone a person has in different parts of the body. And unlike body mass index or BMI, which is simply weight divided by height, DEXA scan can actually give us some meaningful data about fat distribution and percent body fat. And this is a very important distinction in both the general population and actually people living with HIV. If we think about the older antiretroviral medications that people were put on when they had HIV, a lot of people developed fat redistribution, also known as lipodystrophy. Some of these individuals actually lost some of the fat from the face and the limbs, which is known as lipoatrophy, and others accumulated fat in the abdomen or kind of the upper back, kind of like thinking about lipohypertrophy. And so this shifts in the adiposity actually increase their metabolic risk, even though their total body weight and BMI might actually remain stable. By focusing on percent body fat and actually regional fat distribution, the DEXA scan actually allowed us to detect changes that we think are very metabolically important to take into account when we're doing studies like this. You were asking about hydroxyprolines. They actually allow us to quantify collagen, which is the main protein that accumulates in fibroid tissue. Easy to do, is reproducible. The samples are simply hydrolyzed, they release amino acids, and then we use a colorimetry reaction to detect the hydroxyproline levels. So we decided to do this as opposed to doing histology, because the way we collect the tissue, we do a mini liposuction. Sometimes the tissue is kind of broken down, or we might not get enough tissue. We wanted to have an assay that was reliable, and sometimes doing histology, which is what a lot of people have done when it comes to fibrosis, is not really easy to do in some of these samples. And then the last part of the question was about the small samples, right? If the person is lean, or maybe if they already have a lot of fibrosis, we might not be able to get as much tissue as we want to. The other thing to take into account is that lipids can actually interfere with many of the assays that we wanted to do. We actually kind of work on this a lot. We optimize the extraction steps to ensure that we actually had good collagen recovery. We use an assay that is very sensitive for the amount of collagen that we're measuring. And then once we standardized that, we were able to kind of have a very robust and reproducible assay. By combining the DEXA scan with the hydroxyproline measurements, we actually were able to have a more kind of whole body fat distribution plus molecular signaling of fibrosis to look at all the changes that we wanted to take a look when it comes to metabolic risk.
Wow, thank you again for sharing. So my last question for you is about endotrophin. Endotrophin is a key marker of tissue remodeling, and it was identified in the study as a potential early biomarker for insulin resistance in people with HIV. So how might this finding change how clinicians screen for or manage metabolic complications in HIV patients? And how will this research influence future treatment or prevention strategies?
Yeah, so that was really excited in our publications. We actually have a great collaborator who has a lot of great studies on endotrophin. Endotrophin is a breakdown product of collagen 6. The great thing is it's a circulating marker, right? What we found is that in people with HIV, endotrophin levels went higher, and actually kind of track along with the people that have graded adipose tissue fibrosis as well as insulin resistant, right? It will be great if we can actually do biopsies on everyone, but this is really an invasive procedure, to be honest. Is not feasible for large studies, and it's not something we can actually repeat in clinic, right? Circulating endotrophin levels actually mirror the degree of fibrotic change. They can actually help us identify people at higher risk for metabolic complications really early on and really easily, as opposed to waiting until they develop all the complications. The nice thing, as you mentioned, is that endotrophin correlated with markers of insulin resistance independent of the total adiposity. And so that really reinforced the idea that adipose tissue quality, and not just the amount that you have, is actually what can drive metabolic dysfunction in people with HIV. This chronic low-grade inflammation that they have, the persistent immune activation, may actually promote this collagen deposition, increasing the endorphin levels and linking the immune dysregulation that people with HIV have to metabolic diseases.
Yeah, I agree. These findings are so crucial for not only studying SAT fibrosis and insulin resistance, but also metabolic conditions and complication as a whole. Thank you so much for your time and for breaking this down for others that want to learn about the important research happening in UCSF. And for viewers that are interested, visit breakingdownbio.com to read more about this paper and other summaries of other studies. Thank you so much.
Thank you, Michael.